In the present discussion, we have to concentrate on the topic variation of mass with velocity. Suppose an object is at rest, it has one mass. If it is moving with considerable velocity, which means that the velocity of the object is appreciable to the velocity of light, it is having another one mass. Its mass is not a constant. The moving mass m is equal to m0 divided by root of 1 minus v square by c square. This is called variation of mass with velocity. To derive an expression for the concept variation of mass with velocity, consider two frames S and S dash. The frame S is at rest. S dash is moving with the constant velocity v along the positive x direction alone. There is no relative motion along y and z direction. O is the rest observer, O dash is the moving observer. In the frame S dash, consider two elastic balls A and B. A is moving with velocity u, whereas B is moving with velocity minus u. They may collide with each other. After collision process, they coalesce into one body. The momentum of ball A before collision is m into u, whereas the momentum of the ball B before collision is minus mu. According to the conservation of momentum, the momentum of the ball A plus the momentum of the ball B equals the momentum of the coalesced mass. Say m into u plus minus m into u, which is equal to 0. This is momentum before collision of A. This is the momentum of the ball B before collision. Then after the collision process, the two body is reduced into single body, then which is at rest. For the observer, O dash. Let us consider the collision concerning the rest frame S. For the observer O, the things happening in the dash frame are entirely changed. Let us consider the collision concerning the rest frame S. That means for the observer O, let u1 be the velocity of the ball A and u2 be the velocity of the ball B. The value of u1 equal to u plus v divided by 1 plus uv by c square, whereas the value of u2 equal to minus u plus v divided by 1 minus uv by c square. We have arrived at this relation from the addition of velocities. Already we talked about the concept addition of velocities. From that, we have written u1 equal to u plus v divided by 1 plus uv by c square, u2 equal to minus u plus v whole divided by 1 minus uv by c square. For the observer O dash, the velocity of the ball A is u1 and the velocity of the ball B is u2. Now, according to conservation of momentum, according to conservation of momentum, m1 u1 plus m2 u2, which is equal to m1 plus m2 into v. For the observer O dash, mass of the ball A is m, mass of the ball B is also m, but for the observer O, the mass of the ball A is m1, whereas the mass of the ball B is m2. Velocity of the ball A is u1, velocity of the ball B is u2. After the collision, the reduced ball is at rest for the observer O dash, whereas for the observer O, then the reduced ball is moving with velocity v. So you keep this is equation 1. Now you have to write m1 u1 plus m2 u2 equal to m1 plus m2 into v. We know the value of u1, u plus v divided by 1 plus uv by c square. This is the value of u1. Then u2 is minus u plus v divided by 1 minus uv by c square, which is equal to m1 plus m2 into v. Now align the terms m1 into v. Bring this m1 into v to the left hand side. We can write m1 into u plus v whole divided by 1 plus uv by c square minus v. This is equal to m2 into v minus, bring the entire term to the right hand side, minus u plus v whole divided by 1 minus uv by c square. Now multiply m1 into u plus v c minus v into 1 plus uv by c square whole divided by 1 plus uv by c square. This is equal to m2 into v into this term 1 minus uv by c square, then minus to minus plus u minus v whole divided by 1 minus uv by c square. Now you have to simplify this. m1 into u plus v minus v into 1 minus v minus uv square by c square whole divided by 1 plus uv by c square. This is equal to m2 into v minus uv square by c square plus u minus v whole divided by 1 minus uv by c square. Now this v cancelled out. Here also v cancelled out. Now we may modify this m1 into u minus uv square by c square whole divided by 1 plus uv by c square, which is equal to m2 into u minus, write down this term first, uv square by c square whole divided by 1 minus uv by c square. We have right m1 into u minus uv square by c square, u minus uv square by c square divided by 1 plus uv square by c square. Verify it. 1 plus uv by c square, 1 plus uv by c square is equal to m2 into u minus uv square by c square, u minus uv square by c square whole divided by 1 minus uv by c square, 1 minus uv by c square. Now we may write m1 into u into 1 minus v square by c square. Take this u outside, whole divided by 1 plus uv by c square. This is equal to m2 into u into 1 minus v square by c square whole divided by 1 minus uv by c square. Now we may cancel these two terms. U into 1 minus v square by c square, u into 1 minus v square by c square. We may cancel these two terms. Therefore m1 by m2, which is equal to 1 plus uv by c square whole divided by 1 minus uv by c square. Keep this as equation 2. Now we have to find the values of 1 minus u1 square by c square and 1 minus u2 square by c square. Minus u1 square by c square, that is equal to 1 minus, the value of u1 is u plus v divided by 1 plus uv by c square. This is the value of u1, its whole square divided by c square. See here, 1 minus u1 square by c square. u1 value is u plus v divided by 1 plus uv by c square whole divided by c square. This is equal to 1 minus u plus v by c whole square divided by 1 plus uv by c square whole square. See here, u plus v, the c square is taken, u plus v by c whole square divided by 1 plus uv by c square whole square. This is the value of 1 minus u1 square by c square, 1 minus u plus v by c whole square whole divided by 1 plus uv by c square whole square. Now we have to simplify this. This is equal to cross multiply 1 plus uv by c square whole square minus u plus v by c whole square whole divided by 1 plus uv by c square whole square. This is equal to, expand this, 1 plus u square v square by c power 4 plus 2 uv by c square, a square plus b square plus 2ab minus of u by c plus v by c whole square, a square plus b square plus 2ab, that is 2 uv by c square whole divided by 1 plus uv by c square whole square. Now simplify this, 1 plus u square by v square c power 4 plus 2 uv by c square minus u square by c square minus v square by c square minus 2 uv by c square whole divided by this term 1 plus uv by c square whole square. Here this is in positive sign, this is in negative sign, cancelled out, so that this is equal to 1 plus u square v square by c power 4 minus u square by c square minus v square by c square whole divided by 1 plus uv by c square whole square. Now we have to rewrite this, 1 minus u1 square by c square equal to 1 plus u square v square by c power 4 1 plus u square v square by c power 4 plus u square v square minus u square by c square minus v square by c square whole divided by 1 plus uv by c square 1 plus uv by c square whole square. Now this is equal to 1 minus u square by c square minus v square by c square plus u square v square by c power 4 whole divided by 1 plus uv by c square whole square. This is equal to 1 minus u square by c square minus v square by c square. Take this as a common term. 1 minus u square by c square whole divided by 1 plus uv by c square whole square. This is equal to 1, take this term outside, minus u square by c square. We can write the rest of the terms. See here, 1 plus u square v square by c power 4 minus u square by c square minus v square by c square. This is 1 minus u square by c square minus v square by c square plus u square v square by c power 4, 1 minus of v square by c square. This is actually 1 minus u square by c square. 1 minus u square by c square, then minus v square by c square. Take this one as a common term. We can get 1. Already we have taken out this v square by c square outside. 1 minus u square by c square. Now take this term 1 minus u square by c square as a common term. 1 minus u square by c square. 1 minus u square by c square. So here 1 minus u square by c square minus v square by c square is present as such. Take this term outside. 1 minus of, just we have to combine these two terms. We have to take minus v square by c square as a common term. So 1 minus u square by c square. Now we have to take this 1 minus u square by c square as a common term. Then the rest of the terms are already, see this is 1 minus u square by c square. We have taken out this term outside. 1 minus v square by c square whole divided by 1 plus uv by c square whole square. This is the value of 1 minus u1 square by c square. Similarly, we can write 1 minus u2 square by c square, which is equal to 1 minus u square by c square into 1 minus v square by c square divided by 1 minus uv by c square whole square. Just we have to change the sign of u as minus u. This is the value of 1 minus u1 square by c square. This is the value of 1 minus u2 square by c square. Now we have to find out the value of 1 minus u2 square by c square whole divided by 1 minus u1 square by c square. 1 minus u2 square by c square whole divided by 1 minus u1 square by c square, which is equal to 1 minus u square by c square, 1 minus u square by c square into 1 minus v square by c square whole divided by 1 minus u2 square by 1 minus uv by 1 minus uv by c square whole square. See, this is the value of 1 minus u2 square by c square whole divided by 1 minus u1 square by c square. That is equal to 1 plus uv by c square whole square whole divided by 1 minus u square by c square into 1 minus v square by c square. Verify the value of 1 minus u1 square by c square. It is having a positive term. Therefore, this is equal to, cancel these two. We may cancel these two terms. Then we can get 1 minus u2 square by c divided by 1 minus u1 square by c square equal to 1 plus uv by c square whole square whole divided by 1 minus uv by c square whole square. From this, 1 plus uv by c square divided by 1 minus uv by c square is root of 1 minus u2 square by c square whole divided by root of 1 minus u1 square by c square. Keep this as equation number 3, I hope. Just I am taking root on both sides. If you take root for this is 1 plus uv by c square divided by 1 minus uv by c square, that is equal to root of 1 minus u2 square by c square whole divided by 1 minus u1 square by c square. Already we have had the values of m1 by m2. Check it out. The value of m1 by m2 equal to 1 plus uv by c square divided by 1 minus uv by c square. This is equation 2. Say this is 3. From the equations 2 and 3, you know the equation 2, m1 by m2 equal to 1 plus uv by c square divided by 1 minus uv by c square. Say this is equation 2. From the equations 2 and 3, see this 1 plus uv by c square divided by 1 minus uv by c square is equal to this much. But m1 by m2 equal to 1 plus uv by c square into 1 minus uv by c square. From the equations 2 and 3, it is clear that the value of m1 by m2 is equal to this much. From equations 2 and 3, m1 by m2 equal to 1 minus u2 square by c square see that 1 minus m1 by m2 1 minus u2 square by c square inside the root all divided by 1 minus u1 square by c square inside the root. See this is m1 by m2, that is 1 plus uv by c square divided by 1 minus uv by c square. Whereas from equation 3, the value of 1 plus uv by c square divided by 1 minus uv by c square is this much. Therefore, m1 by m2 equal to 1 minus u2 square by c square divided by 1 minus u1 square by c square. From this cross multiply, m1 into 1 minus u1 square by c square inside the root equal to m2 into root of 1 minus u2 square by c square. Both of them are equal to a constant, say m0. m1 into root of 1 minus u1 square by c square equal to m0. From this, m1 equal to m0 divided by root of 1 minus u1 square by c square. In the same manner, we can write m2 equal to m0 divided by root of 1 minus u2 square by c square. Now consider a particle of mass m and moving with velocity v, then m equal to m0 divided by root of 1 minus v square by c square. See this previous case, m1 is the mass of the object A, m0 is a constant called rest mass, that is equal to 1 minus u1 square by c square. The mass of the body A is m1, velocity of the body A for the observer at rest is u1. Now in our case, if you assume that the mass of the body is m and its velocity is v, we can write m equal to m0 divided by root of 1 minus v square by c square. This is called the variation of mass velocity. This is rest mass, this is moving mass. Suppose an object is moving with velocity appreciable to velocity of light, its mass is not a constant, it is also a variable. Now the Newton's second law is invalid. If the object is in the classical limit, we can apply our Newton's law. Suppose the object is moving with velocity appreciable to velocity of light, that means closer to the velocity of light, its mass is not a constant, it has two masses, one is rest mass and another one is moving mass. If v equal to c, then what is the value of m? If v equal to c, put here v square by c square, that is equal to c square by c square equal to 1. So anything by 0, infinity. So this quantity is 0. 1 minus v square by c square is equal to 0. So m approaches infinity. In this way, we may conclude the concept variation of mass with velocity. If we say that v is greater than c, which is imaginary, because if v is greater than c, the quantity is in terms of negative value. That means inside the root, if you put I, that is I square, root I square is equal to I. So it is imaginary. Therefore we may conclude that known object may move with velocity equal to or greater than the velocity of light. That is a conclusion we have to provide.